Okay, in the previous class, uh, we are discussing about the impact of software patches on the digital switching system maintainability. There is one type of patches they are introduced in the modern DSS. That is the embedded patcher concepts. Okay, where ಎಲ್ಲಿದ್ದಪ್ಪ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಎಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಬೇಕಾಗಿತ್ತು report the method for reporting and correction of field problem is over, no? That is over. Okay, we completed that part of first half part of this model 5. Okay, in the previous class also. Next we have to one more thing is that diagnostic capabilities for proper maintaining of digital switching system. Okay. In the previous class, what we are discussed means we are discussing about the how the report will be means what are the methods for reporting and correction of field problems. Okay, here we have taken some important fault. Okay, one is the testing failures and FOA. FOA is nothing but FOA. There's a first office application failures, operation failures, and failure observed during the upgradation process. Okay, these are some of the various fault reports. Okay, these fault reports will be taken from the various sources, okay, such as testing, like example is the FOA failures, and then failure observed during the upgradations, okay, and then CO failures. Okay, these are the failures. Okay, all the reports, okay, sent to the database. That's called the fault reporting database. Okay, that can be utilized to record the correction history and assign the fault report numbers and fix the priorities. It may be a minor, it may be a major, it may be a critical. And also same times they track the time required to fix the problems. Okay, then the fault reporting matrix resolves the problems and forward to the owner module for the corrections. Okay, the same thing report will be sent to the owner models. Okay, depending on the type of the faults, the module owner can solve these problems in the present generic programs. Okay, we are using some of the patch coders to resolve the particular problems. Otherwise, they will postpone to the for the next generic programs. Okay, in the next they're releasing the next generic program now during that particular time. There is all this issues. Okay, there's a two option they're taken for this taken by this owner model as a model owner to solve these particular issues. Okay, after that the fault reporting matrix can be used to record the current correction history. Okay, this can be used for enhanced to break down the causes for failure, and also we can easily can analyze what is the root causes for the particular faults. Okay. Okay, till this we are discussing the previous class. Next we are discussing about the important topic, that's the diagnostic capabilities for proper maintenance of digital switching system. See, for the maintenance of DSS, effective diagnostic programs are necessary and this can reduce the maintenance cost. Okay, ಅಂದ್ರೆ ನಾವೇನ್ ಮಾಡಬೇಕು, effective diagnostic program ನಾವು proper ಆಗಿ maintenance ಮಾಡ್ಕೊಂಡು ಹೋದ್ರೆ we can reduce the maintenance cost. Okay, in the earlier day, what is the circuit packs, also called as a plug-in or circuit card assemblies, are necessary in maintenance. Circuit packs will be stored in COs, but they are very costly. Okay, and then the CO, central office, is remotely managed by ACC and then ESACS. And these two, okay, request the DSS maintenance program that support the remote diagnostic as well as they provide the high accuracy diagnostic results. In the fast switching system, improved the large number of types of circuit packs and diagnostic capabilities. Nowadays, all the modern DSS are using a smaller number of circuit packs, become a single high-density circuit packs, impact many functionalities of digital switching systems. The diagnostic, how to do the diagnostic in the for proper maintenance of a digital switching system. In earlier days, what happened, their number of circuits will be more. Okay, circuit pack is nothing also called plug in, plug out. Okay, there's others inserting the circuit cards assembly for okay, for that things we need to we regularly should do the maintenance the particular circuit packs. Okay, we can see observe if you go for your DST lock, digital circuit packs. Okay, we have them some model will be there. Just you have to plug in the card, plug in the circuits. You can varying the input, digital input will get the variable output voltage. Okay, during the inserting the plugin. Okay, what happened? Sometime what happened? The wire will be disconnected. Okay, this is also one of the maintenance. Okay, in olden days, what kind of switching system is there? We are using the large number of circuit packs. It is also called as a plugin, a circuit card assemblies. Okay, for this, can we need the maintenance? Okay, these are things like that means you can need the necessary for the maintenance. Okay. Uh, see, okay, these circuit packs. Okay, these are the circuit packs that be stored in the COs. Okay, but these are very costly. Okay, these COs and also central office can also remotely managed. Okay, diagnostic via SCCS and ESACS. Okay, these two are the these two request some of the DSS maintenance programs that can be used for means it can be support for the remote diagnostic as well as the provide the high accuracy diagnostic system. Okay. In the past switching system, I put the large number of types of circuit packs. Because of that, we need to necessary for maintenance and diagnostic capabilities. In modern DSS, whatever, the number of circuit packs will be less. Okay, as a single high density circuit packs impact many functionality of the digital switching systems. Okay, okay, these are the capabilities. Capabilities means how much is required for maintaining the particular CO. In the earlier, we are comparing with the earlier switching system and the present switching systems. And also, what is the effect of firmware development on those systems? Okay, ಏನು ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ ನಾವು ಒಂದು ಸಾಫ್ಟ್ವೇರ್ ಡೆವಲಪ್ಮೆಂಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಏನು ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ? Okay, the effect of firmware deployment on digital switching systems. Okay, see the recent trends in the distribution process of digital switching system has resulted in increasing the software. Okay, what happens? See, we are giving the we are adding the some of the lines. Trunk lines are line models, trunk models. Okay, it means for goes on increasing the number of lines, number of special circuits can also increases the number of softwares because each model is having a some control program. Sorry for the delay. See, see what are the effects? Okay, what are the effects would be of software development system in the recent times in the distribution process of the digital system as a result in increasing user software. So that's what we have. process functions. What is the difference here? One, the software is a substituted information system and software impact completely because everything is not modern DSS. One called this software control. Okay, that's why the software suppose the software that's why you should properly maintain the software. Okay, every time you upgrade the programs in the particular system. Okay, that's why there's a huge impact in the subscription of infrastructure system and the subscription DSS for the code for the process of putting bringing the system on the system. So basically, how much it is? Then this software is also often used to run the program codes in the DSS. Okay, we have device. And this zero, that's a different memory. Space right there, you want to store the particular before the devices. Actually, this software is always used and including the programs stored in the devices. And coming to the element, it's also different. Executable data which are stored in the semiconductor basis. Whether using nowadays are used for storing this program. Now with the trend towards the distribution architecture, the use of probability control embedded in the system is rapidly. Like an there is a physical representation. There is a data executed and stored in the semiconductor. Okay, the semiconductor can access memory on a quasi-permanent basis. Okay. For this request, there is some physical replacement of the interpretation with an external in this term towards the distribution architecture in the DSS. Because of that, they are distributing the systems in the DSS. They can also support the through the system as increased requirements. The interfaces are different. The density also there. Everything. Okay, that the DSS 20 to 30% of their programs embedded in frameworks. Okay, nearly 30 to 20 to 30%. This will be actually the present switches are main function on the function DSS. And then line jobs are capable for printing the line origination, termination, transmission, service, circuit, access, and also some of the software-based requests to connect media and provide the local memory and line service and manual intervention with external equipment for updating. And then this updating process may involve erasing or modifying the program or specific programs, and actions of the host system. We have different types of memory, electronic software. See, during the update process, the system controls not being stored in the sequence. If the process will not happen. That's why what is nothing but the impact of software. The software is failure in this system. That's what I will get the problem. There is nothing. And update some of the patch codes or fix the patch code for particular main programs. Okay. And these are the 30% of the control program being okay. Because of all the substitution control process, some controls. Okay. Then there is the completion of the first part of the module. So the second part, what are the things we do there? Okay, second part, generic data setting system. Display because it is part of the solution. So this deadlock resolution close can do for a set of deadlock process. Let us say we have a process P1, process P2, process P3, like this. These many have deadlocks, let us say. Out of the process from P1 up to P7, out of these many processes, so these three processes got started. Okay, this resolution we can actually do, but the set of deadlocks. So D is what? D is the breaking of it. So D is the see what are the contents are there in the model file. Okay, we go see we are discussing about the what is the digital switching system model. Okay, we are discussing about the generated digital switching system model, and then hardware architecture, software architectures, and how they are recording the things information from the SME engines and automation mainly because like warehouse and models. There's a recording strategy, but also simple cluster data switching. The simple cluster related data switching, same thing. We are using the model 3. Okay, that's a okay, we are discussing how the hardware works in the digital switching systems and what are the common characteristics of digital switching systems and reliability analysis. Okay, these are the content of the model second part. So we can have one or see the first thing in this topic we should focus on the what are the strategies for the digital switching system. So the strategies of going for improving the software qualities. Next, okay, directly we move on to the hardware architecture. But before going to that, we should know what is the strategy for improving the software qualities. In order to resolve this, to do the resolution of this, we need to achieve this resolution by avoiding. See, yeah, see, the strategy for improving the digital system quality, it is based on the process matrix. Okay. The process matrix of data analysis and continuous improvement program. This is one of the strategy we can improve the software quality. Programming matrix and following this process of the process one by one. Okay, and again, detailed analysis. Okay, any detailed analysis we can analyze the real time and continuous in the program. Okay, suppose we can example in the well matrix. Okay, so software matrix is process matrix and matrix in the quality matrix. Okay, this process matrix is nothing but is a two matrix given in the quality reliability measurement process critical matrix. Okay, in that system, and also we have some classification to increase in the process matrix. Okay, process matrix. That would be the program. Okay, first we have some software process method analysis matrices, and then program for software process process. This is a program for software process improvement. Okay, actually, this program, okay, software process improvement, the program is out of the system. Okay, software process improvement system are usually large and complex because the number of subprograms are interconnected with the main programs, and then customer elements we have given the data system. We discussed here that we have to enhance the systems. We have some of the additional components like number of lines, assigning the number of lines, measuring the number of lines, main lines. Okay, that's why for each and every system we are using the programming software. That's why this software process for digital switching system are usually large and complex, and these processes must be documented on basis by putting them under the configuration management system. Okay, this configuration management system, if any changes to the process or to the process, because of that there is no right? So which one to take? And this the process changes does not always improve a processor, but continuous improvement of program can be improved by using this process. And this again, this continuous improvement of program, this currently CPA strategy is with different processes and objects and these strategies in this assume that the process can be instrumented. So again, the second classification is implementing the software quality. The second is the software processes. This also be including the some of the classification. It is again software testing process, software development process, and software validation process. After that, we are adding one more thing: the matrices. Actually, the matrix is the strategy. Now we are adding matrix of this strategy. And this strategy can be applied to work in a set of matrices. So that is called the software development matrix. The software development matrix located like singles. Phase of the software development process as a development matrix. Second is the software testing matrix. Again, it is measured the effectiveness of software testing process. And then software development matrix. Okay, it is matrix collected during the development of user the used C++. And next is the software maintenance matrix. Okay. This also same thing. The matrix the most of the important matrices are the number of software patches and the number of effective patches count and effective diagnostic program. And then customer satisfaction matrix. Okay, this is must be able to collect from the customer DSS. For example, billing errors, sudden data from the consumption, so that sometimes the disconnected, some slow from and the other system next is the diagnostic analysis or effect analysis. Okay, suppose incident people the system continuously improvement program is can be adapted for managing the performance of the software. Okay, that's why during this continuous operating system, every time this diagnostic the monitoring what is writing and that is every time we can monitor the whole system. Okay, anything is bad in the system. What are the necessary action should be taken? Okay, that's why we are using some of the strategies as a step. This step defect analysis is a base program thing. This carrying values and the user will have input and output. Okay, and the field okay, the field failures, there may be patches of once as a classic machine, if you want to find out that it's a minor filters. Okay, it may be critical, maybe major, it may be minor. Okay, and these are some of the analysis we are doing to improve the porosity of software. Okay, after this, after that, now we are going to go on to the particular section. Part 2 in the introduction. Here we are going to study the functionality of this outage switch to explain the performance of the typical class by class by the basics. Okay. In the basic class basic class they call it the different terminology. Different network in the aspect of the class one is the lowest, okay, class one is the highest. Class one to class five. Oh, actually, in the class one is the local exchanges, okay, and the basic local exchange. What kind of thing hardware and software used to cross functionality switching systems. Okay, that's why this chapter we are going to study the what are the functionalities of the present system and also to explain the software for the typical class five system is nothing but a random local exchange. How it is working, what the functionality is, and study the exact functionality switching system. Okay, and then slow. Okay, actually the generic digital system that is algorithms of the architecture, the typical customers switches and trace and convert the functionalities of an operation digital system. The system requires statistics for the observable digital system, and also we can read these are the important topics studied in this particular module. Now we are directly to the first one is
Sir,
yeah, you can.
sir, some disturbance is there, sir.
Now it is audible, no?
Yes, sir.
Okay, now we are going to discuss about the hardware architecture. Okay, with this, what we have seen that the block diagram of
ನಿಮ್ಮ ವಾಯ್ಸ್ ಸ್ಲೋ ಆಗಿ ಕೇಳಿಸ್ತಿದೆ ಸರ್ ನಮಗೆ.
ಹೌದಾ? Okay, dear students, just you maintain just you note on these hardware architectures. Okay, now it is audible now. Say sir. No?
Yes, sir.
Okay, now you should take on this block diagrams. Okay, these are hardware architecture. What are the main contents of the hardware architecture? Can set up also NCPs, interface controllers. Okay, we are distributed structure we have there. Yeah. Okay. Please note on this hardware architectures. Okay, everyone should please note on this figure. Okay, see these are the line models. Okay, line models, trunk models. Okay, these are remote models. It is clearly visible now.
Yes, sir.
Okay, please everyone, please note on this block diagram. Taken heading is the hardware architecture. Everyone, please note on this. Once you completed, once you inform me, we will go for explanation. Okay.
Completed, sir.
Okay. Completed?
Yes, sir.
Okay, dear students. See, in this case, we can see observe what are the things are involved in this hardware architectures. Okay, it is a quasi-distributed control architecture. Okay, distributed architecture. You can see observe there is a number of CPs. There is a number of NCPs are there. The NCP will be which have a number of interface controls will be there. Okay, there should be all these NCP and then all the switch fabric controllers and all these NCP and then ICs and all the line modules or trunk modules, some of the special modules. Okay, remote modules. Okay, all those things will be connected to the central processor. Central processor is one of the main uh, network. There's a primary processor in the digital switching systems. Initially, you can see observe this is one of the typical digital switching system hardware architectures. Okay, it is based on the quasi distributed control architectures. Okay, it contains many subsystems. Okay, you can see it has many subsystems. Okay, the architecture of DSS is very complex because of it contains many subsystems. Okay, it consists of some of the following main models. Okay, what you are this one what we are showing in this figure. These are the main important subsystem or interconnected to the particular DSS. Okay, in this the first important subsystem is the central processor. Okay, this is represented by CP also. It is also called as the main processor. It is the primary processor of the digital switching system, and it is always duplicated. Duplicated means one more thing will be there. Okay, okay. Auxiliary central processor also will be there. Duplicated means suppose if anything go wrong in the first DSS, the test okay ಏನಾದ್ರು ಫೇಲ್ಯೂರ್ ಆಯ್ತು ಅಂದ್ರೆ ಮೇನ್ ಸೆಂಟ್ರಲ್ ಪ್ರೊಸೆಸರ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಇನ್ನೊಂದು ಡೂಪ್ಲಿಕೇಟ್ ಇರುತ್ತಲ್ಲ ಅದು ವರ್ಕ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ. ಓಕೆ, ದಟ್ಸ್ ವೈ ಇಟ್ ಇಸ್ ಅ ಮಸ್ಟ್, ಇಟ್ ಇಸ್ ಆಲ್ವೇಸ್ should be duplicated. Okay, in any central office, so if you go for any central office or local office, there's a central process will be there. Okay, this is our main processor in the digital switching system, and it is always a duplicate. Duplicate means one more process will be there. Any issues will be occur in the first processor. The work will be continuously. I mean, the work will be taken from another central processor because this digital switching system will operate in the real time. ಅಲ್ವಾ, ನಾವೇನಂತೀವಿ ಡಿ ಎಸ್ ಎಸ್ ಯಾವಾಗಲೂ ರಿಯಲ್ ಟೈಮ್ ಆಗಿ ಆಪರೇಟಿಂಗ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಎನಿ ಫೇಲ್ಯೂರ್ ಬೇಕಾದ್ರೆ ಸೆಂಟ್ರಲ್ ಆಫೀಸ್ ಮೀನ್ಸ್ ದ ಹೋಲ್ ಥಿಂಗ್ ವಿಲ್ ಬಿ ಶಟ್ ಡೌನ್. Okay, that's why to overcome this one, we need one more CP, central processor, the absolute central processor. If anything will be happen in the main, then they take the second processor will be that take the whole workload and continuously it will be operated. See, what is the function of this central processor? The function of this central processor is to provide the wide control of the switching system, and also it supports the secondary process. We can see secondary process is also called as a network control processor. Okay, the function of the central process is to provide the system wide control for the switching system. It is supports the secondary process. It is also called as a network control processor. And the CP central process is a high-level functions of switching and support the operation, administrations, maintenance functions. You can see above in the figure also. Okay, it supports the operations, administration, and then maintenance function. And then the CP controls the system recovery process during the critical fault. The CP also maintains the subscriber and office data. It's supporting the filling system of the switching. Okay, you can see up in the block diagram. What are the things what are the subsystems we connected to the particular central process? You can see the tape units, printers, maintenance control, and also will be a disk will be there. It means that the CP is it supports all the operation, administration, and then maintenance functionalities. Okay, they can also work with sometime what happened during the critical fault. You can recover the things data from this CP Okay, and then the CPU also will be maintains the translation data as well as the subscriber or office data, and also will be supporting the billing system for the switch. Okay, that's the working of the central processing the picture switching system. And second one is the network control process that is represented by NCP. Okay, NCP is nothing but it's a secondary process. Okay, you can see what are the things they will interconnect to the NCPs. Okay. They provide the call processing function. Okay, through this NCP only they provide the call functioning process, and also assist in setting up the path through the switching fabric. ಅಂದ್ರೆ ಏನ್ ಮಾಡುತ್ತೆ ಅದು ಅಸಿಸ್ಟ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಸ್ವಿಚಿಂಗ್ ಫ್ಯಾಬ್ರಿಕ್ ಅಲ್ಲಿ ಯಾವ ತರ ಕಾಲ್ಸ್ ಲೈನ್ಸ್ enable ಮಾಡಬೇಕು ಅನ್ನೋದು. Okay, and also many number of NCPs are present in the generic switches. Okay, they are also usually duplicated and depending upon the desired size of class 5 central office. Okay, ಇದು ಅಷ್ಟೇನೆ, ಅಂದ್ರೆ ಈ NCP also duplicated ಆಗಿರುತ್ತೆ. Okay, duplicated ಆಗಿರುತ್ತೆ. And also these NCPs, okay, we can see in the observe in the block diagram, NCP also will be interconnected. Okay, or interface with the interface controllers and provide the medium level call supporting process. Okay, it can also provide the medium level call processing support. And also NCPs are also associated with a particular ICs. Okay, to keep the track of the calls controlled by the ICs, and associated to the, and also will be associated with the assignment of the path. Okay, and also NCP is also with the CPs. Okay, to update all the path on regular basis for global view of all the calls for the other NCPs. ಅರ್ಥಾಗ್ತಿದೆ ಅಂದ್ರೆ ಈ NCP ಏನ್ ಇಂಟರ್ಫೇಸ್ ಆಗುತ್ತೆ, CP ಸೆಂಟ್ರಲ್ ಪ್ರೊಸೆಸ್ ಇಂಟರ್ಫೇಸ್ ಆಗುತ್ತೆ, ಮತ್ತೆ ಅದರ್ NCP ಪ್ರೊಸೆಸ್ಗೂ ಇಂಟರ್ಫೇಸ್ ಆಗಿರುತ್ತೆ. Okay, to updating the call path on regular basis. Okay, that's why the NCP is actually associated with the interface controllers to keep the track of all calls controlled by these interface controllers, and also associated path assigned for it, and also NCP interface with other CPs or NCPs to update all the call paths. So this the NCP is the second main part subsystem of the digital switching system. And third one is the interface controllers. Okay, the most of digital switching system employs a processor based controllers that act as a concentrator of all the incoming line and trunk. Okay, here all the incoming line and trunk line and some of the remote modules or special modules all are being interconnected with the interface controllers. Okay, that's why the interface controllers actually it is employed based on the controller, and also it acts as a concentrator of all the incoming and trunk lines. Okay, in these concentrators, sir, in these concentrators are used time division multiplexing systems are used for to make the connection between the line modules and then as well as the trunk modules. Okay, and next important component is that switching fabric. Okay, next is the switching fabric. Okay, as usual, the switching fabrics. Here, how they connected in the switching fabric means based on the space or based on the time switching configurations. Okay, sometimes what happen, they're using the time switch configuration, other space configurations. Okay, generally they're using the concentrator. Okay, in the ICs or a timer. T switches. Okay, sometimes space switches are often used for this accessible for all the NCP in some cases. Okay, these are the 5 important subsystems are used in the hardware architecture. Okay, today we'll stop here. We'll continue the next class. Okay, thank you. If you have any doubt regarding today's section, you can ask me any questions. Any doubt today? Any doubt regarding today's session? You can ask me any question. No doubt means you can leave the session. Okay, once again, thank you.
Thank you,
Thank
sir.
you, sir.